I highly don't think that it fell out of your book. Yesterday we practiced on lesson 3, and we're moving back to lesson 2 now. Mainly because I wanted you guys to understand like what size of what makes an equilateral triangle, what makes those things, and then we'll go back and we actually measure because this should be pretty easy for you today, I would say. So put your name. We're gonna staple all these together again, but put your name up here. I'll put Mr. Young here. And I can't find them. 909 to 914. Check that up there on top. I took that one from you too. See it up top there? You had 2 of them. I didn't know why you had 2 workbooks for. All right. Hello. Yeah, exactly, math time. We just did a Kahoot. I was trying to do it from my I'm recording right now, but tried to do it from my rolling cart there, but Chromecast doesn't want to work today. All right, so the essential question is we should always ask, and we've done it through all the videos, lesson 2, which is how does geometry help me solve problems in everyday life? All right, now I'll tell you what, I wish I had paid attention more in elementary school because I've been building this that greenhouse. I don't know if some of you have seen it. I showed some of you. And I tell you, the hardest part of building this greenhouse has been the beams, the trusses, the roof. Because what shape is usually a roof? That has been the hardest thing to build for me because I didn't want to have, because I'm tall, and I didn't want to have a beam go across, where I'm walking like this, because it would have been easy for me just to make a triangle for my roof. But I wanted to have the roof come down and sit on the sides so that I don't bump my head. Some of you don't have to worry about that, but I do. Mikey has to worry about that too, right? So getting this 2 sides of a triangle just right and getting these angles just right to sit on this board, it was the toughest thing. And it was trial and error. I wasted boards after boards after boards, and I finally got it right. But I bet if I'd listened in math class, I probably would have had a simpler way to solve that problem than wasting precious lumber. All right, so today a triangle is a polygon with 3 sides and 3 angles. Now I'll give points to any house right here. If you can tell me, what is it called? A triangle that has 3 equal sides and 3 equal angles, I guess. All right, Ravenclaw. All right, I'll give you some points here. I need to mark that down somewhere. I'm working on the back one of these right here. Ravenclaw, 100. All right. What is it called when a triangle only has 0 sides that are equal? Asher thought I was going for the 2 one. Go ahead, Colton. No. You weren't here for that yesterday, but you remember Emmeline? Scaling. I'll give Gryffindor. Now they're looking right now, Mr. Pritchard, right? Yeah, at their they made a jam board with their notes, and so we've been adding to that each day. So yeah, scaling, remember, has no sides that are equal. And then Asher Thompson, who I know who wants to answer this, what's one that has 2 sides that are equal? Isosceles, and we couldn't pronounce that much yesterday either. I can easily pronounce that. Okay, isosceles. So a triangle is a polygon with 3 sides and 3 angles, and you guys just named the 3 types of triangles we talked about yesterday. So we're going to measure the sides of each pair of triangles below to the nearest 1/10 of a centimeter, and then we're going to record those measures. All right, so using that ruler, how many of you have this? Raise your hand if you still have this. Shocking if you do. It's great that you do. Okay, well, use your scissors and cut out that little piece of paper right here instead of wasting more time. All right, so we're going to measure each side here. Do we start with 1, 2, 3, 4? Do we start with the very edge? No, remember we don't. Remember we said we can kind of cut that part off right there. So if we measure right there from that line to that line, what's the nearest centimeter? Let me pull that down a little bit more there. Now, what's the nearest? 3, right? It looks like, if you can zoom on down there, it looks like 3. And there's really no way we can do this on the smart board measuring these things, you know what I mean? So this is 3 centimeters right here. So let's measure this one right here. What does that measure? Pretty close. It says nearest, so we'll say 3. And what do you think this here measures? So what kind of triangle do you think that is if they're all equal? It's a regular polygon, yes, but equilateral. Remember, so I'm going to write equa, and that's what we learned yesterday, but we learned the terminology yesterday. Now I want you guys to see it, so we had to move back a lesson. Let's measure this one over here. Somebody tell me what that measures. I'm not going to measure it. You tell me. 2. You guys agree that this measures 2? Looks like it to me, close enough. What about this one right here? 2. What do you think this other one measures? So again, what's this triangle? Equilateral again. And why are they equilateral? Same sides. And because they have the same sides, what about their angles? Well, yeah, they are acute, yeah, and typically equal. All right, so let's measure this one here. What's this long one here measure? I'm not going to put... You need one? Give him this one. What's that measure? 4? The bottom one? That one? Nearest, yeah, nearest would be 4. So let's put that as a 4. What about this side one? 2. So what do you think that one's going to measure? I would probably say if I was guessing, but I'm still going to measure it anyway. 2. Everybody see that that's 2? Is everybody measuring this with their rulers? So what do we notice about this triangle? Okay, so someone else though, 2 equal sides. What is that 2 equal side one called again, Maddie? A what? A scoscoli? What? Close enough. Isosceles, yes. ISOS, isos. Celes. Isosceles. 2 sides are equal. Now we could name these as 2 different things, but we're just keeping it easy right now. But this next one, I think I'm going to make you guys answer this one, all right? So, if it works out like I think. What's this one here measure? The bottom one. 2. Let me clear that up a little bit. Okay, what does this right here measure? Okay, what does this one right here? Close enough. So give me both names. If a house, I saw Emmeline's hand first. Give me both names of that triangle like we did yesterday. Remember we had 2 different names for it. It's a right. And you said isosceles. Is she right? And I'm going to put that for a triangle for shorthand since time. All right, so is that Gryffindor again? Okay, so we have a right isosceles. And why do we know that's a right triangle for? What gives that away? Ireland. The little mark in it, this little guy here gives it away that it is indeed a right triangle. And then we have isosceles. Why is it isosceles for? 2 sides are equal. What about this right here? What could we call this one here? What else besides isosceles? I saw your hand. It's not equilateral because equilateral, remember, they all have to be the same. We got the isosceles part, so no. What about, look at the angles. What does this angle here look like? Is that 90 or more? More. What's that called when it's more? Obtuse. Obtuse. So this would be an obtuse isosceles triangle, right? Slytherin, I'm going to give you some points on that one. Good job. Remember, the equilateral, we don't have to name it anything else because that's what it is. It's equilateral. Everything's equal. All right, down here, pair C. Well, let's look at the angles first of all. Can we tell what kind of triangle this is based on just looking at the angles without measuring the angles? Go ahead, Johnson. Huh? Now, acute, they all have to be acute. Laura? Huh? Look at this right here. Is that a right angle? Obtuse. So we know that this one's obtuse, but let's measure the sides now. What does this top one here measure? All right, Johnson. This one right here. Yeah, we'll go 4. It's the closest centimeter. What about these bottom ones over here, Lauren? What's this bottom one here measure? Oh, okay, I got you. Johnson. And what about this one right here? We're going to go 2, and she said scalene, so I'll give her that one, scalene. She knows it's scalene. So it's an obtuse scalene triangle. And Johnson, I'll give you some points there. And since you got that one, I'll give you half the points on that one. All right. Yeah, I'll give it to you too. Good job. All right. Now, what kind can we go ahead and name this? Since we see that one thing right there, sailor. Okay, it's a right triangle, so put right there. All right, now let's measure the sides. And what does this bottom one here measure? 3. What about this top one? Pretty close to 4, right? Because it says the nearest. And what about this one over here? What? So this is a right what? Scalene, as Ireland said. Right scalene. Right scalene. Pretty simple, right? When you break it down, when you know your notes and you've got them right there in front of you, it's pretty easy. So we don't need to do this right here. It says compare the side lengths of each pair of triangle. We did all that information up there, so we can go ahead and skip on. Turn to the back side here. All right, so we don't have, you do have a protractor right here. How many of you are, Ant, how many of you guys are familiar using a protractor?
Me. What's it look like? Circle. Half circle.
All right, so in measuring angles, which you would have done last year had you not been sent home forever, you would have done this with a protractor in 4th grade. And it's pretty easy. Like you would basically extend all these lines out further so that you have something to measure it with. And then what you do is, these are all what they call vertices, places where it meets. Everybody see that? And then what you do is you stick this right here. See this black arrow, the line? You stick this on the flat line, like right here, and you put that arrow pointing at that dot. And then you come up here and you say, what's that angle equal? 90 degrees, right? So this would be a 90-degree angle. We could actually call it that if we wanted to. And then you just spin your paper around and you say, okay, well, again, this flat part needs to go on that line right there. See the line that right here, this line? You put that on there, and then you take that little dot and you stick it on the dot. I didn't extend this line out, did I? And then where does that line go to? It goes right here about between the 30 and the 40. So what's between 30 and 40? You can't see it. 35. Now you can't see it very well, but I know this is 35 and not, if you notice that there was a different one here, right here. See, there's 2 numbers here, this top number and this bottom number. How do I know that this isn't 150 degrees? How do I know this isn't 150? It'd be way too much, right? This is a acute angle. This is less than 90. So you got to look at that and see that it's less than 90. But we're not really doing that this time. So what I'm going to have you guys do, instead of measuring the angles on these, I want you to measure the lines. All right? I want you to measure the lines like you were doing with your ruler in centimeters, like we did on the front page, and then put each side, like this one here is going to be to the nearest, so we're going to say this is 4. We're going to say this one here is about what? About 3. And this one here is going to be about pretty close to 2. So what kind of triangle is this? It's a scalene. What kind of angles are all these? So you'd say this is an acute scalene triangle. So that's what you guys are going to do on this assignment right here on the practice it, is measure the sides of all these and then tell me what each of those are. Down here at the bottom, see right here? I want you to do the same thing, but I only want you guys to measure. So don't measure the angles, measure the sides. Mainly because protractor is a whole other topic we need to discuss. And right now we need to get the fact that we're measuring these sides to know which triangles these are. None of these are right triangles, or right angles, sorry. None of these are 90-degree angles. So I'll let you know that much. So none of them are the little squares. Your only homework tonight is 4 through 11. You don't even need your homework sheet. So your homework tonight that you're doing right now is only 4 through 11. Nope. Okay, you don't need your homework. I just want you to do those 8 problems. And remember, measure the sides and then describe the triangle again. Okay? Huh? Yep, just on this page 911. 9. Ugh, that's a bad number. 911. Okay?